Sorry for this slow start. We have today a very distinguished panel, and we are very happy being with you today. And based on what we heard before, you will see we will try to work on these three values: safety, technology, and the human aspect. We will try really to work on those three, and you will see that beyond our respective titles, beyond what we do, we are passionate. We really enjoy, we really like to speak about aircraft, we really like to fly, we really like to keep people dreaming, as you said, Yannick, how to ensure that the next generation will help us to still do business in a very safe manner. So today in the panel we have Koen, the DG of the Belgian CAA, but not only this, you are also the chair of our board, EASA board. So welcome on board, if I may say. And beyond this, I would like to highlight a couple of points for each of you. I've picked up in your CV some key issues. Sorry, I'm coming back to the microphone. It's still not working. Apologies. So Koen, as the chair of the management board, but also as the chair, the DG, sorry, of the Belgian CAA, you are passionate. You started to live.
Merci. Sorry, finally. Merci. Bon, so let's rewind. That's what we call unexpected event, upset recovery, and now we're back on a smooth flight. So Koen, sorry, I come back to you now. The chair of the management board, DG of the Belgian CAA, but also since your earliest age, a passionate of aviation. And you may not know, but Koen has renovated an aircraft, a small airplane. So when we speak as a regulator, as an authority, competent authority for oversight, I think you really know what you are talking about. And when you speak about how to train the human aspect, how to get new people on board, I think you are also very active in a few aero clubs in teaching to people, in training them in terms of theoretical knowledge. And this is really part of our DNA, how to really transfer our knowledge and competence to the community. So thanks a lot, Koen, and we look forward to your presentation. Mark, it would be too long to resume to summarize your career. You have done almost everything. From safety, from ATC, ops, safety assessment, crisis management, and of course, you have been a regulator, CAA UK regulator, and in this respect, I think you really were very instrumental on working on performance-based regulation, how to transform the UK regulatory system from prescriptive, descriptive environment to a really performance-based environment, which is a key enabler for new technologies. If we are prescriptive, we are an obstacle as a regulator to new technology development. So many thanks for being with us today. And in IATA, you are now just consolidating all what you did before for the benefit of Airline Association in terms of safety and risk management for the sake of the worldwide airliners. So thanks a lot. We had, until a couple of days ago, Anna van Groot, the DG from UK. Unfortunately, she had to cancel on short notice, but she has been really kind to us, and we have a video from Anna. And Anna, you will see, has also a very interesting message, which is very well aligned with what Florian, Yannick mentioned before, in terms of how to manage competencies. Rolf, also, a very long career. You have been in the heart of the academia and research development since, I would say, day one. DLR, you have been part of the board of DLR, ACARE, NLR, no, sorry, excuse me, the competitor to DLR. So you have been working a lot on the various scientific advisory bodies. You work with Clean Aviation, you work with some academia still, and most important, we have been together working on some model-based development project, no science fiction, what we call the virtual product house, which is a kind of virtual element of a future single-aisle wing, which could be fitted on any similar aircraft by definition. So pure model-based development, pure research, but no science fiction. And today, because of course you have to retire, you are managing your own consulting company, and we are still very happy to work with you. Yann, I have a lot of respect as a pilot for former Navy test pilots. This, I have to say. always impressed. You are really flight testing for years, and you have joined the Airbus flight test and more recently Yannick Safety Directorate with a very interesting background on new systems, new equipments, and in particular visualization on the modern generation aircraft. So you know what we mean by new technology, by not yet AI, but almost, and you know, and you can talk about it, the importance of the human and the training of the human into the loop. So I won't keep you busy longer with this introduction of the panel. Very happy being with you again today. And I will leave the floor to Koen, if I can find here it is, for the first speech. Thank you, Koen.
First I'm going to try the microphone. Is it working? Okay. Okay, then I've been to talk about the link between civil aviation and the role of technology within civil aviation. Let me start by saying that the relationship between CAs and new technology is not always a happy one and purely joy. It's a lot of concerns as well. In a short time, things like AI and other emerging technology are disruptive for us. Let me give you some examples. For example, if we deliver a license, how do we do this? Well, by using very prescriptive legislation. If you want to obtain your PPL license, you have to have had 100 hours of theoretical training, 45 flight hours, of which 25 hours dual and 10 hours solo flight, so very prescriptive. Now, if you look at the possibilities of AI, of virtual training, we can easily move towards customized training for individual pilots. You might change the way you teach your pilots to become better pilots faster by using this type of individualized training concepts. But then the next question is, how do you do the oversight? So for us, that's not that easy. Another example, aircraft inspections. We used to have engineers who knew exactly which bolt you needed to use at which part of the airplane, at what torque you needed to apply. But that type of knowledge is not sufficient anymore. When we send people to check an airplane, they have to be aware of the SMS, cybersecurity, information security, and other types of inspections, like the inspections that you need to do with composites. So basically, the type of profiles that we used to apply, that we used to attract to do these oversights, well, it's not sufficient anymore. Another example, look at what's happening at air traffic management at the drone level. That's completely new for us. We are not talking about ATCOs who are managing traffic as persons. We are talking about introducing information systems who will do the traffic management for us. But hence, what's happened? What's our role? As a CEA, how are we going to do the oversight? That's not clear for us at this stage either. Just to demonstrate that at a short time, new technology is disruptive for us. Basically, it's even in this stage, a country like Belgium, we are not able to cope with it on our own. It's too much coming up. So actually, what solutions do we want to look for? Well, basically exchanging experts. We will need to collaborate with other CEAs. We will need to collaborate with EASA. We have to do knowledge sharing. I'm not capable of gathering all this knowledge on our own fast enough. And what's more, in the short term, we need to adjust the regular framework, like the oversight for licensing. If we keep working with the legislation as it is now, we will not use the opportunities that information technology gives us. But on the other hand, it's not that we are against technology, far from it. We do see a lot of opportunities. For example, training our own staff. We can use this technology to train our own people, our engineers, and so on. Furthermore, artificial intelligence, well, it can help us a lot with risk-based oversight. You know, risk-based oversight is a very nice approach, but determining the real risks and where to do oversight, well, artificial intelligence might give us some hints and might help us to have a better understanding of the risk and where to base our oversight on. And automation of repetitive administrative tasks is another opportunity. Just to mention that at a short time for us, it's disruptive, yes, and we need to act and we need to collaborate and we need the help of EASA. But on the long run, it will give us a lot of benefits as well, and that's something I'm convinced of. Just to set the scene, that's the way CEAs look at technology, at least CEAs like the Belgian one. Thank you.
Okay. Okay, so the role of technology in enhancing aviation safety. So I'm going to cover a few themes around what we do in AI. But before we begin this story and this journey today, I think it's also important that we reflect on where we were yesterday and maybe a bit beyond yesterday. And when we look back at 1950, the first kind of views of AI were starting to emerge with something called the Turing test, where we were trying to trick humans into believing they were interfacing with a human when in fact they were interfacing with AI. AI, artificial intelligence technology, has become an absolute buzz at the moment because of the amount of press and how we're using it in modern day activity. But it started way, way before what we're using today. Between 1950 and 1986, there was a somewhat of what was described as an AI winter. And I think, again, something that we may touch on as we talk about the panel. And that AI winter came about because there was not enough political backing or regulatory backing or understanding of what we were doing, which left AI on a bit of a backbench of how it was developing. But it started re-emerging in the 1980s. And in 1986, we saw a pivotal moment where Geoffrey Hinton released a paper which he was describing something called backpropagation, and he was starting to demonstrate how learning and generative AI could be utilized. Now this basically is the fundamental basis of what we're building a lot of our AI architecture on today. So we can see that actually yesterday we are still moving on. And I do like to say 1997, where we saw AI start to really challenge a very substantial human in his particular field of expertise, where Garry Kasparov was beaten in a 6-match thriller of chess playing against AI. So really interesting how this has evolved. And today, in 2022, well, little while ago, but 2022, we started seeing the emergence of things we were starting to use on a daily basis in things like ChatGPT, Alexa, Siri, all of those things really starting to come to the fore, all forms of AI. But in aviation, what is our reality today? We're starting to see AI become embedded in a lot of the things we do across the aviation infrastructure and system. We're seeing things particularly being very much customer focused at the moment. And I think this is, excellent opportunity. It brings a better experience to those engaged in commercial activity with aviation, whether it be ticket sales, whether it be in-flight sales, whether it be how we determine which meals we should be applying to the menu on aircraft. But as we're moving forward, we're seeing this starting to emerge into things like predictive maintenance. We're starting to see crew rostering, and all of these things are great opportunities for where we are. But equally, and as we are with EASA, and we've sort of talked about the importance of safety, I think we also need to understand as well, where do we leverage this from a safety benefit point of view? And how do we free up humans and SMEs to become more effective with the time that they have? And I've just put a little table on there that I think as we expand our use of AI, we have to build in a significant amount of trust in what we have and what we use. So I'm just going to introduce you, and by no means is this a sales pitch, by the way. Obviously, this is a product that we have in IDX. It is free, it's voluntary, so it isn't something that we're selling. But I just wanted to give you an idea of how even at IATA that we're looking to leverage these solutions to understand the vast amount of data that we receive through our incident data exchange program. And you can see we have 289 participants worldwide with around 1.4 million reported incidents recorded. Now, the challenge we have with this is we don't have the resource to really go through these with a fine-tooth comb and work out exactly what are pinch points or what are areas that we may need to be looking at from an IATA perspective to support the aviation industry. So, what we are working on at the moment is this very transformative way of using AI to siphon through those reports to actually get some intelligence that we can use to actually start building maybe safety priorities or where we need to influence or advocate across a number of domains. I'm not going to go into huge depths as to what each of these areas do, but what it does do is it allows the translation of foreign languages, of sort of identified data into de-identified data that we can then start sharing. And it allows us to look at building, maybe increasing the taxonomies that we use to measure. So what we have been finding is a lot of our reports will sit into the bucket that is defined as other or unknown. And actually, we know there are trends in there. We know that that's actually probably a really good pot of information. We just need to be able to understand, and it takes time. But actually, this is one of our opportunities, and I think it's really important that we consider actually where do we leverage our opportunities to utilize the best time and effort. And again, just a very high level, just to show you that, how we work through the various steps, how we're using generative AI to recognize where there may be new taxonomy codes or where we may be missing data or where we're looking actually at cross codes as well. But I think the really important thing on the right-hand side of this is how the human still has to be involved at every step of this process. So things need to be validated because context is key when you're looking at vast amounts of data, and sometimes maybe it's the human that will detect where that context lies within the current day. So the other thing that I wanted to touch on, because obviously we know where the opportunities are, but I also wanted to touch on where the threats are. Okay, because this is something that we don't maybe talk about enough in a lot of areas. And I've broken this down into a very simple human system and environment piece, with the operation kind of how we function today often sits within that middle zone. When we look at the human perspective of this, and I've talked very briefly on trust, but I think we can also start thinking about actually, is there a lack of transparency sometimes with the data set that we receive from automated systems? And how do we sort of resolve that so that we're not looking at obscure decision making? But equally, when I sort of think about actually, do I have an example of that? Of course, I've been to many meetings where you go there with a focus and you put up a data slide and you spend half an hour of your meeting trying to work out how do we get to that data point. And I think that will be a challenge that we will have to face as we start using automation and artificial intelligence going forward. And I think, for me, the key message here is we have to trust what we are building. I think as well, from a human perspective, we need to look at actually what are our ethical implications, and I'm sure we maybe touch around those, during the panel as well. But ethical values within how we use AI and not removing that human-centric touch is absolutely key. When I think about the system, I look at actually is there societal biases that we may arise or be amplified through the use of such things as training data, or even through the algorithmic design of the system itself. So I think it's very important that we keep an eye on actually those biases that may arise from the data sets that we use. And interestingly as well, and I will bring it up, but I also think we've got to be really cautious about being over-reliant on this stuff. I think it's an amazing opportunity, but I think as well, actually, do we want to maintain some of our own cognitive elasticity and thought when we are also going into this? I think there's a real balance to be struck about not removing our own ability to think when we are designing or creating systems and so on. And then finally, when I think about the environment, and thinking more about the regulatory sphere here, the liability and culpability that comes along with AI solution, particularly for decision making, is something that I think we will have to focus on now and in the future as things start to evolve. I see there being challenges around safety accountabilities for sure, and it's important that we address those. And then moving kind of into the sort of thinking around actually how does this correlate with our cybersecurity obligations and intellectual property rights and data security. I would also say as well, and just from sort of saying that the hub that I sort of view in the middle being our operational space, I would probably say as well that I would be really cautious around AI dividing that gap between how us as a human interact with systems and components and actually how the system is being utilized. So I think it's really important as well that we look at actually making sure that we keep these things overlapped so that we function as we have been. So that's pretty much all from me. I think we know evolution is coming. I think we have to embrace it, and I think there's so much opportunity for us to explore, but being cognizant of the fact that AI technologies are maturing much faster than us as the human in the system. And I would also be guarded about leaving societies behind in this, thinking about ICAO's drive and mantra around leaving no states behind. So I think we have challenges, we have opportunities, we have threats, but we also have a very exciting future.
No.
I'm sorry, yes, we apologies. So we have to go to Anna.
Here we go. Yeah, it works. So, at first, thank you very much for having invited me. It's a sort of new community for me, but I'm really happy to talk to you now on this issues, utilizing technologies and maintaining the technology flow. Start with the core subject of our panel, the technology to enhance safety in aviation. We can structure this, let's say, technologies on the vehicle itself, the aircraft or the drone or whatever. I picked as an example a gas sensor. It has been flight tested already at Airbus some 20 years ago, in a big program where we installed a gas sensor under the cockpit of an A340. On top you see an example of a helicopter from JAXA, the Japanese agency. So a gas sensor for sure is for safety. It's also for improving the weight of an aircraft, and with this you can do gas load alleviation, as I decrease the weight. That has some implications, of course, on safety, etc. So this is a top topic, not very new, but still under discussion right now for the next aircraft. From vehicle to operation, again, just as an example, sectorless ATM, it should have read air traffic management, which you probably know that an air traffic controller in front of a screen doesn't look at sectors, but leads an aircraft from point A to point B. That would be a new way of managing the air traffic, of course also linked to safety in aviation. From operation to the whole life cycle of an aircraft or of a system, MRO, maintenance, repair and overhaul. Example would here be structural health monitoring for maintenance, repair and overhaul. Circular aviation is a key word right now. Structural health monitoring, with this you can really work on predictive maintenance. And on the one hand side, it's good for the aircraft and for the customer, for the airline, but of course also in terms of safety. Certification itself, and Alain already mentioned the virtual product house, which I picked here as an example, the simulation-based certification. Just heard about AI. As far as I know, in robotics and AI, they had a new expressions on simulation reality gap. It's quite an interesting one, and there are some. I'm coming from aerodynamics personally, and some aerodynamicists still think that they have the first flight in the computer. That may take another few years, I don't know. But this gap between simulation and the reality, something we really have to look at. But it's an interesting topic to work on this virtual product house, what we installed a couple of years ago. And finally, talking about the system, and this will be the major part of my talk. So the system, whether it's the advanced air mobility, whether it's mobility as a service, as a new topic right now, and linked to all this, of course, a cybersecurity system. So cybersecurity is part of mobility as a service. We are all somehow affected by this. and this asks for special technologies to help with this. So that would be the broad area of technology in aviation, and just a low-brainer technology is needed for different topics: efficiency, reliability, seamlessness, safety, security. So every design is a multi-purpose design. It's not a peak design, very specific on efficiency whatsoever. It's multi-purpose. So we may degrade in a certain topic in order to have a complete balance for the sake of the whole thing and for the system. Now, in enlarging the view a little bit, we have the aviation system as described, with the vehicles, with the operation, with the maintenance, repair, overhaul, with the end of life. Now we have other systems, like the mobility system. We have the use options, the vehicles, passengers, cargo, infrastructure, and the link to the aviation system via the door-to-door transport, via the impact, the service, and the pricing. We have the energy system: energy, electricity, heat, mobility, housing, storage, infrastructures. And again, of course, this is linked to the aviation system by engines, by our energy storage, or SAF, or batteries, or hydrogen, whatever it is. We have the security system. Every day more important, security of critical infrastructures, people, food, health. So on the aviation part, we look on prevention, detection, maybe counteractions. And at the end, of course, the welfare system as such, where we're all part of, in education, jobs, health, and of course, the aviation systems linked to this. So we have to widen our own activities to not stay in the aviation system, but look for integration in other systems. In Europe, we have an activity called ACARE. It's an advisory council for research and innovation in Europe on aviation. And ACARE published an EU vision on aviation some 2 years ago at the Berlin Air Show. And if I may just quote one sentence out of it from this EC aviation vision: the aviation system of systems is increasingly being seen as one indispensable embedded part of a broader system of systems, providing mobility as a service. And while presenting new opportunities, these developments raise new safety and security challenges. This is very true. So if we widen, we have to think about technologies, other technologies, and have to embed this in our own system. Just 2 examples. Number one, on MRO, digital threat with a D, not with a T, so it's a digital threat. As an example, we have an Eurofighter, we have the speedbreaker of a Eurofighter, and there has been any impact, stone hit it, whatsoever, so it's been inspected by a specialist. The specialist thinks about a repair method, and then, of course, carries out the repair. So we have the whole chain from inspection, analysis, the method, bill of materials, the MRO action, and finally the report, and as a safety critical part, certification. Then we have the digital twin before the repair, the digital twin after the repair. And every change to the digital twin, if it's a real one and a serial one, must be traceable, must be secure, must be authorized. Probably this may ask for blockchain technology, and now think about the implications in terms of computer power and IT. This is just one small part for just one small aircraft. Now we talk 20,000, 40,000 big transport aircrafts, every one 3 to 5 million parts each, staying in the air for 30, 50 years, and doing all this with blockchains. So we have, to a certain extent, to weigh the CO2 reduction. Just CO2 is just one example, reduction through digitalization, which is good, configuration and others, but also the increase to digitalization for all the data centers we use. And somebody has to weigh this up. Somebody would be the society. We haven't found a solution yet. Example number 2, on humans. We talked about this already. New paths without guides. This is a study I borrowed from the RAND Corporation. You may know it's a US military think tank. It's quite an old study, 2006. I show this picture more than once. I think it's self-explaining. They just picked up all the military aircraft over the decades in the US. But I think it's understandable. You could write it and have the same picture for civil aircraft in Europe or wherever. You see the 50s with all the variety aircraft we still know, the F-104, Starfighter, the C-130, the Hercules transporter, B-52 and others, the 60s, 70s, etc. And if you enter a company, as you see these things on the top, 40 years career span, if you enter in the 50s or 60s, you have seen many, many aircraft programs. Learned a lot, failed, learned again, do the next program better and more. Now if you enter a company right now, there's probably not too much to be learned. There was, as I said, studies from 2006, and you see in the 2000s they saw the JSF, the Joint Strike Fighter, which is the F-35 right now, and an UCAV, an unmanned combat air vehicle. So, RAND says, and I think that's a good point, we believe that the declining experience level has been a contributing factor to the problems we observe in many recent aircraft programs. A380 has not more progress than others. It was just a time when also the new Airbus company, the EASA, was founded, but it has also technical problems, as others, as 787 and others. Now we go ahead and change this known aircraft to the game changer of the future. All this fancy stuff, hybrid electric and blended wing bodies and whatever may come. I think it's not only true this what Rand says for the specialists, but this affects the management level at which decisions are taken. That's at least as much as a specialist. So this lies in front of us. That leads me to my key messages of the day. So in order to make future decisions based on knowledge, we should make more use of large programs, like you probably know the Clean Aviation Program, the EASA program, the other big programs, fuel cells, joint undertakings, others, just to maintain experiments on the technical as well as on the management level. For an unbiased approach to explore new technologies, we need more open research at universities and at research institutions, not oriented towards expectation and need of politics and industry, but really being open to find these new revolutionary ideas we are asking for. In the past, we have been really successful in aviation safety. Safety efforts have already been very successful. So now aviation must play a more dominant role, if not, and I think it could be a pace setter, in a cross-sectoral approach. System of systems, this asks for a new look at technologies and also on safety. And finally, to meet all these challenges with this system of system view, we need more living labs, more fun and different funding mechanisms to manage all this. That's it from my side. Thank you very much.
We go for Anna. She's ready. Anna is ready to be la vidéo de Anna est prête.
Tu veux la mettre maintenant?
On va la mettre maintenant.
Okay.
So sorry, we had a small problem with the timing with the sequence on the video. So now Anna van Poel is coming with a recorded video. Sorry for the small timing issue. So, Anna,
good afternoon to all of you. I am really sorry I cannot be with you today and join this distinguished panel and all of you in person in Budapest. But I am very grateful to the EASA team to facilitate this short video message and allow me to share a few thoughts with you. This panel is looking at the role of technology in enhancing aviation safety. Well, I think it's a well-established truth. Since the very beginning of human flight, technological advancements have contributed to making aviation safer, one little or big step at a time. Thanks to these innovations, today aviation is one of the safest modes of transportation. One of the keys to success is that aviation has a strong culture, placing safety and security at the very center of all our activities, even and especially as we introduce new technology. A complementary framework of regulations and standards is a cornerstone of innovation in aviation, as it provides the environment that enables the development and adoption of new technologies and ensuring global interoperability. We have many examples of success where we achieved this, but let me just cite a few. Avionics that support safety systems such as ED250 on runway overrun awareness and alerting systems. Runway incidents and accidents still being identified as one of the main killers in aviation. Connectivity standards that enable strong and robust communication between the aircraft and the ground at all times. Standards that support increased navigation performance with predictable and consistent aircraft behavior, allowing more efficient use of the airspace, thereby increasing capacity and safety. Improved collision avoidance systems, providing a safety net, including coordinated avoidance maneuvers, and so many more. Today, the aviation industry is evolving at an unprecedented pace, driven by technological advancements, regulatory changes, and shifting global priorities. Standards play a crucial role in facilitating the adoption of these new technologies by providing a clear framework for their implementation. With large research programs like CESAR or Clean Aviation progressing quickly towards making Europe the most efficient and environmentally friendly sky to fly in the world, to cite CESAR, the red thread throughout the innovation pipeline must be continuously monitored and nurtured. And we have great examples on how we can work in a very integrated approach, like the remote towers, ED240, which standardizes the performance specifications for these systems. It facilitates the integration of remote tower systems into the aviation infrastructure, promoting safety, efficiency, and interoperability across different airports and countries. This standard is essential for ensuring that remote towers provide a level of service equivalent to, or even better, than traditional control towers. As the R&D work continues to progress, the standard is evolving to include more functionalities, such as augmented with visual tracking-based object motion indications, automatic pan-tilt zoom object following functionalities, and non-optical surveillance sensors, along with recording and playback requirements. And work continues in our Working Group 100 to enhance the document even further. This is recognized worldwide, and we know that today ED240 is recognized as the global standard for remote tower implementation. As I said, regulation is a critical aspect of the aviation industry, with safety being the foremost concern. Standards are closely aligned with these regulations, providing the technical details for compliance. EUROCAE works closely with EASA and other regulators to ensure the standards development work program is complementary to regulations and to the EPAS, providing to the community a set of robust and complete tools to demonstrate regulatory compliance. And we try to work together from the very beginning. For example, when SC-VTOL was issued a couple of years ago, we agreed a work program between the industry and the EASA, which the Working Group 112 is now working through under agreed priorities. And this is really always the best. A working group where industry and the regulator can work together to agree on the standards needed and develop them in a consensus-based, transparent way. This creates confidence and leads to robust results, and ultimately makes the entire system stronger. This is why we're now using the same approach in other areas. With the new regulation on ATMA as ground equipment, EASA will again rely on industry standards to support the implementation of this new framework. Proposals are being discussed on how this can best be achieved, agree on priorities, pursuing a collaborative approach again between the regulator and the community. Our new Working Group 130 will kick off on 18th of November, so there's still time to register if you haven't done so yet. As aviation systems become more digital and interconnected, we see more and more components using artificial intelligence being introduced. The introduction of AI into aviation brings both opportunities and challenges, requiring a well-defined regulatory framework to ensure its safe, ethical, and responsible use. We see it happening today already. It's not future anymore. For example, we recently published an updated standard for foreign object debris detection systems, ED235A, which notes that today AI applications are able to recognize objects in many different situations and therefore provide the user with a pre-identification of the FOD and an estimate of its size, which can be very useful, obviously. But more fundamentally, addressing AI, we obviously need a transversal and holistic approach. I'm very happy that we're working very closely with the EASA AI team in our Working Group 114 to develop first statement of concerns and taxonomy to lay the groundworks, and now the first standard to enable the introduction of AI-based technology into the aviation sector. ED324 will come out for consultation next year, and more will follow, again very closely coordinated with the AI roadmap. But as we see more technology, including AI, being introduced, the systems also become more vulnerable to threats. AI, in this sense, is certainly a blessing and a curse at the same time. Identifying the challenges AI-powered malware and ransomware pose is a new and growing challenge for the aviation industry. Adaptive threats, more targeted attacks, automated exploitation or data manipulation are only the tip of the iceberg. At the same time, the use of AI will enable us to effectively safeguard critical infrastructure, ensuring resilience against AI-powered cyber attacks. Standards for cybersecurity being developed to address the unique challenges of protecting our critical infrastructure. These standards provide guidelines for securing communication networks, protecting sensitive data, and ensuring the integrity of systems. By following these standards, stakeholders can reduce the risk of cyber incidents and ensure the coordinated and continued safe operation of the airspace. Again, here, the EASA Part IS and the industry standards are very closely aligned and coordinated. In all of this, obviously, we cannot solely focus on Europe. Aviation is by nature a global business, and our links with ICAO, regulators and stakeholders from the US, EASA, and other regions are paramount. The collaboration with our partner organizations, RTCA and SAE, on many of the subjects as cited is crucial to achieve global interoperability and international harmonization. These are just a few examples of innovation we see happening today, and there's so many more it's hard to pick. What I wanted to highlight here is really the integrated approach and the close collaboration between EASA and EUROCAE as standards development organization. And at this occasion, a big thanks again to the entire EASA team for the excellent cooperation on these and many other subjects. By having an integrated approach of regulations and standards, we can create a robust yet flexible framework that allows industry to innovate and certify. While standards are often perceived as restrictive, costly, and slow to be developed, all of which might be true at times, they should much more be seen as a strategic tool for the future, enabling innovation, not stifling it, creating trust in a given technology and facilitating its safe and secure deployment. As the aviation industry continues to evolve, the need for standards will only grow. As I conclude, I guess my message is innovation is not new. Aviation has always been an innovative sector. As with all technologies before, we need to crawl before we walk and run. But the pace accelerates, we have no time to lose. So let's not be afraid to start on the path, in fact we're already on it, and take it at our own pace. At EUROCAE, our commitment is to develop high-quality, consensus-based relevant standards that support your needs. Together, let's continue to drive the standard for innovation. By fostering collaboration, robust, relevant, and timely standards, we enable the future of innovation in aviation, paving the way for a safer, more efficient, and more sustainable aviation industry and continue our journey of innovation. Again, my sincere apologies for not being with you, but I hope these thoughts can spark a bit of discussion at the conference or the future occasion. In any case, thank you very much for your attention. Enjoy the event, and I hope to see you soon.
Okay, good afternoon. I'm Yann Beaufils. I've been a test pilot at Airbus for the last 10 years. Just before joining Yannick's team about a month ago, I was the flight test referent for the A350 program. And before this, I worked on several functions and on the design, especially on vision systems. So I'm going to give you a little insight of what it is to go to the office at Airbus as a test pilot, working with engineers on new functions, and I will give you a bit the design perspective. So we have design drivers, and the very, very first one is safety, and safety beyond standard, meaning that at Airbus, we don't stop at what is required, but we work on everything we can think of to improve the safety of our product, our functions. And it's a very first concern we have when we want to make something new. The number two driver is efficiency, because this, we can sell it to the customers in every possible way. So we can sell more fuel-efficient aircraft, more weather-resilient aircraft, improve ground operations, reduce maintenance cost, maintenance time, shop time, and pilots also to provide functions to the pilot to make their job easier and more efficient. And the last thing we don't always think of when we talk about technology, AI, etc., is that we design aircraft to carry people. And some of them are quite stressed when they take an aircraft. And at Airbus, we want our passengers to be happy and have a happy experience in our aircraft. And so lately, we've worked on the seats, on space. You've noticed if you've taken a 380 or a 350 that we've worked a lot on the silence, a very quiet environment, so it's very comfortable for the passengers. We have reduced also the cabin altitude. So from roughly 8,000 on the 320, 330 generation, we came down to 6,000. It doesn't look like a lot, 2,000 feet, but when you take an aircraft for 10 hours, at the end makes a big difference. And we can put also as an option moisturizers for the cockpit and for the passengers as well. So comfort is another driver. Every time we launch a function or an improvement for efficiency or comfort, it has to come to point number one every time. So we won't do anything new without passing the safety filter. And we work also on services. So a little bit about Airbus research and innovation. I won't tell you the story of Airbus for the last decades, but innovation is in our DNA. And as a manufacturer, we invest a lot of money. We put the best engineers, the best test pilots as well, yeah, it has to be a pilot. And we go to the edges of the upcoming technologies. And to talk just personally, my career, I have got a lot of grace behind about stalled functions that we never completed because it was not efficient, it wasn't bringing any value to the company. And a lot of them were stopped because there was a slight doubt about the fact that it could damage the safety level. So the innovation at Airbus, yes, but it's not at any cost. We won't put innovation just for the sake of it. We will go through again the three first bullets. We will put innovation to improve safety, to improve efficiency of our aircraft, and to improve the comfort of our passengers. And be sure that there will be no trade-off with safety at any point. It's really a driver. Every time we're in office at a meeting with pilots, engineers, it's the first thing we have in mind, okay? Today, on the 350, which is the latest aircraft in our inventory, the level of safety is achieved because we have two humans in the aircraft, assuming they're both in the cockpit at the same time. So the job of the pilots has evolved, but still the brain of a brand new 350 is still organic and is still an Homo sapiens Mark I who's flying this aircraft. And the system remains human-centric. So as I said, the training will change a little bit to adjust to the change of the pilot functions, but it will remain at the heart of an advanced system. So basically everything we do technologically to improve the aircraft, it's around the pilots to help them doing their everyday job. Thank you.
Well, thank you all. Sorry, I still have a small cold going on, but thank you all. That was very, very instrumental and very to the point. As we said, safety, technology, and human. So very, very good. Before going to the Slido, maybe a couple of questions to you, just to initiate the discussion. Starting with you, Koen, you mentioned in your presentation from a competent authority perspective that you have a plan and there is a need for short-term actions. And in this respect, you have started to develop a bit. How do you see the role of competent authority and the EASA evolving in the future in that respect to enable this development, to facilitate this transition to the new technology in a safe environment?
Yes, well, I don't know if the microphone is working. Yep, okay. Well, basically, one of the problems that we have is that we need to acquire a lot of knowledge and expertise at a very short time. And we are not able to do so. We are a public entity, so my resources are limited, and the ways I have to attract people are limited as well. So what we need to do is to collaborate with other entities, with other CEAs, but also with the EASA. And this gathering of information, bringing together knowledge, and sharing experts is a role that EASA can do, will be very helpful if they can enhance this, they can help the CEAs to share information and so on. That's one thing. Share experts is another thing. And there are some steps taken to exchange experts and to put up some kind of a system to help countries to do so. And then when we talk about legislation, well, you need to adapt the legislation to be able to grasp the real, to maximize what you can get out of new technology. There are three issues that I think are important as far as EASA is concerned.
Many thanks, Koen. And as you know, we're working on the rule simplifications. We have a number of initiatives in that respect. So that's really what we have to further develop. Maybe a quick question to you, Mark. It was a brilliant demonstration on how AI can help in analyzing data. And back to what we said before, the importance of data sharing and data analysis. And we are all working on our system. We have data for safety, you have your system, the FAA. Everyone is working on this analysis of data, on trying to have a safety risk management system, driving some indicators and so forth. Do you see at some stage the new technologies, not only AI, but globally speaking, do you see them as an enabler to share what we started to do all together to build this kind of collective safety risk management system? It's a dream, but maybe it can come true.
Alain, I think it's a great sort of point to discuss. I think when we look at sort of key reporting repositories, data for safety, ECAS previously, ASIAS, and you've also got things bubbling away in Singapore where they're looking at things like AP share. What we will become very quickly is data rich in aviation. In fact, we're probably already very, very data rich already, and what we can't do is rise to the challenge of both time and resource. So I think maybe it's not a question of if, I think it's a question of when. And I think our big challenge with all of these things is all of the systems at the moment have a slightly different, either an input method, a language that we use, a taxonomy that we use, an input and output, and all of those things. But I think with AI, and particularly generative AI and sort of those learning models, we should be looking to get ourselves in a position where our output can be equally consumed by each other's programs across the globe, so that we end up with more of a global system risk picture rather than what we have now, which is very regionalized issues. I mean, let's be honest, aviation isn't regional. It's not based in one state. We are a global commodity that is used, and we need to understand the challenges on the east side of the globe as much as the west side. So I fully agree that I think that the sooner we can start thinking about collaboration on data, as sort of Yannick mentioned earlier, that data sharing and how we get over those hurdles of data sharing is absolutely key. So I think it's a question of when.
Many thanks. That's really instrumental. And just to continue in that respect, Rolf, I would like to come back on your Akare statement or quote. There are a lot of very, very competent people in your working group. So I'd like to use a bit of your brain, human brain, not AI for sure, and your experience here. You mentioned that aviation as a system of systems have to be more and more considered as part of a more global system of system, societal maybe, in terms of transportation mode, door to door, let's say. And you mentioned that you were a bit concerned that this will introduce new challenges, safety and security. Just a few hints on this. What were your first ideas in Akare when you spoke about that?
Well, I would be glad if I would have that idea to have the complete transport system, because I think we have to think more in passengers' view. Right now, we all have, I wouldn't call it bubble, but we have our aviation system, we have the rail system, we have the road system, and we work in this. We have, as we know, all the different big programs in EC. We have clean aviation on the vehicle, we have CSR on the operation, we have fuel cells, and so it's all, and we have somehow, as Reagan said some 35 years ago, tear down the walls. So we have to really think about a complete system. I mentioned the sectorless ATM, so I would now advocate something like the sectorless PTM, the payload transport management, that we really think about this. And if we then think about a passenger entering from door to door, let's say in an airport. Today we have the land side and the air side. And maybe tomorrow will you think about how can this be combined as a single system that may lead to other maybe gates and then to another design of an aircraft. So this will be linked then finally also to vehicle design. But we have to think more across the borders, across the sectors.
Many thanks, Rolf. Just about the Airbus approach and the Homo sapiens Mark I, because we are still all Homo sapiens Mark I. We have a lot of additional support, but in this environment of new technologies, not only AI, we should not focus on AI, we should not hijack this discussion for the purpose of AI development, but more globally, new technology. As you brilliantly demonstrated, Airbus and other manufacturers, research institutes are working on new systems and so forth. And we are going to this safety beyond standards, so the aircraft is certified, and we want even to improve it in today's environment, in today's CONOPS, with 2 human beings at the control. So in this development, where we have more and more tools for the crew, how do you see the future role of the pilot evolving in the next decade, let's say?
Well, the job of the pilots have already evolved a lot. When you think back of the 50s and 60s, the pilots were literally struggling with the aircraft, flying it, trimming it, etc. And then the technology came and we developed autopilots. And today the autopilot, frankly, fly better than we do, like to turn with a good rate, not to have the champagne spinning over. So, and we have put a lot of safety functions on top of it. And so the basic flying skills of the pilots that were required in the 50s and the 60s is not that required anymore. And we've tried at Airbus to remove a little bit this of the hands of the pilot, to leave them with the high-level task, which is thinking, taking appropriate decision in order to bring the passengers to destination in a safely manner, efficiently for the fuel, etc., for the timing, and also with comfort for the passengers. And so more and more, we've seen that the role has changed from a handler to a manager, a system manager. And I don't think that in the next decade it will change a lot. It will keep that track of managing more and more the systems and to keep the high-level tasks for themselves.
Well, thanks a lot. Yann, maybe back to you, Mark, on this last point with your background, not only from IATA perspective, but performance-based, competence-based development and so forth. How would you complement from an operator perspective, Yann, quote, we had the manufacturer view, which is we have a more resilient aircraft and the role of the pilot will evolve toward this, it's an evolution, so it's normal. And how do you see it from an operator perspective? How to value this growing role of the crew?
It's a challenge, isn't it? I mean, I think utilizing technology and AI to understand better how we perform daily is critical, and there are already systems out there that are doing that. But I think with the opportunity that we have, I think we're looking at sort of how do you get more from the system to understand actually the human performance within that system. I think that's where we're really aiming in that respect.
Which is a good link to what we heard before, and also to what you said, Yannick, in terms of the next step, how to work better together, how to improve the aircraft's resilience, how to also from an operator, how to use data, how to share data, not only for the purpose of aviation, let's say, airworthiness purpose, but also in terms of human performance to improve our training, to improve the way we work, the crew, CRM, and so forth. Maybe, sorry, Koen, back to the competent authority. Do you have some views in that respect, how you see this from an oversight perspective, from both the pilot, but also the airlines? This evolution, how to facilitate the role of the crew, and how to redefine our approach to training and to oversight of those functions.
Well, I do think, as I mentioned in my presentation, that the training of pilots and crew will be enhanced by the new technology. AI will enable to develop training more individualized, more focused toward the weaknesses of pilots, of certain crew members. But that poses a challenge of oversight, because AI will help you to determine where you can cut corners and where you can go faster within education, but it will not tell you the reason why. You do not have the causal relationship. So how, as a CAA, you're able to determine whether this has happened as it should be. So that's a challenge, for sure.
I'm sure you agree, Mark.
Yes, I mean, it's been a couple of years since being in the environment, but the UK CAA rolling out sort of performance-based oversight, and I think when we were sort of going through the journey of sort of inception and then learning about the amount of data that we were gathering from doing a different type of oversight, where not only were we, sort of meeting the regulatory obligation, but also gathering more soft, critical elements, sort of things, around staff churn or safety culture promotion or whatever it may have been within a particular safety framework of performance-based oversight. But the challenge was then, how do you utilize that information to then plan your next set of oversight activity that is more based on the risk or the challenges that you saw within a particular, whether it was an AOC, whether it was an aerodrome, whether it was an ANSP. But and I think looking forward, I think we have to look at saying, there is a model out there of AI solutions, of technical opportunities that provide us with really clear insights. Now, our job will be to turn that into the intelligence that we then plan our audit activity with. For sure, it is not going to be 100% accurate. And I think, but equally, what I would say now is where we even conduct sort of within the EASA program, which is transitioned into a risk-based auditing environment, even under a traditional method of compliancy checks, you will not be able to identify critical safety issues that exist below the surface of an operation. So even though compliance monitoring and compliance checking will give you that surface level, moving to a risk-based approach will give you more opportunity to find where those latent threats are existing in the industry and do something before they manifest into something more nefarious. So I think that's where our real opportunity lies. It's first gathering the data through your conventional methods, your new approaches, your risk mindset and your risk sort of prioritization, but then sort of leveraging AI and technology to really give you that critical intelligence to say this is where we should be going or this is where we should be looking next time. But I guess no system will ever be 100% spot on, because actually it's just a snapshot in time at the end of the day during an audit.
Very well, thank you. Just before going to Slido, to be fair to Anna van Groot, who is not here, I think she would have really be right in the middle of the discussion with us today. She's sharing most of what we said. You heard from her speech. And just to highlight the importance of, from a regulator, and also from a manufacturer perspective, the importance to work on those industry standards, to facilitate the new technologies. That's where we can really work on the future easier but safer means of compliance, performance-based, risk-based. And here we have to say the SDO and standardization bodies are doing a great job to support the authority and industry as well to do so. So without this kind of standard development, I think we would have real difficulties to cope with the pace of the change. So again, a big thank to Anna by default, and I'm sure we'll follow up with her. So we have now a chance to have a look at the Slido. We had quite a few questions. I was monitoring the last few seconds. And I'm afraid, Yann, we start with you, obviously. What a surprise. So up to you, Yann.
Well, it's a hard one. I don't have I don't think there is a silver it's a bunch of things that will come together that will bring safety improvement. But there is nothing I can think of that would dramatically increase the safety in the next decade. I mean, obviously there is a technology, so we're working actually on for instance, on the 350 for the autopilot to be permanent. So it will be pretty soon unlosable, I would think. So the pilots will have always a functional autopilot. They have a bunch of functions that will help greatly the pilots to deal with the worst failures, and the two worst being the dramatic decompression, and the second one would be a smoke and fire. And for the dramatic decompression, we already have an answer on the 350, but we'll try to apply it to other platform, is the auto-MR descent. So when you have a decompression, basically what you have to do is to very quickly get out of the airway and descend to the ceiling, put a mask on, and it's a lot to do for a crew. It's a big emergency, and for the cabin as well. And on the 350, for a few years now, we have a automatic function that does that for you. So instead of having one pilot flying and the other one trying to think, the aircraft does the cutaway, the descent at VMO, MMO, it stops at a safety altitude, and then you have two pilots thinking. And there are a bunch of bricks like this that will help the pilots to get back some cognitive resources in order to better cope with the unexpected.
If I may, because I like very much your sentence, the two pilots thinking. I think that's very important, in fact. If we want to differentiate what are the top 10, it will be very hard, as you mentioned. But if we really want to release the pressure on the human being, if we really want to allow their brain to be more available for other decisions which are also of a very important critical safety nature, the more they can think, the better it is. So I would really, from my former certification, if I may say, background, I would fully buy into this. We have to help in the future the crew to have more bandwidth to analyze what's going on. Would you agree with this?
Bandwidth is one, and the second one is at analyzing past accidents, Airbus or not. We want to avoid the cliff effect, where everything goes well, and within seconds, the crew is completely lost, and we want to change the MMI to prevent this from happening, etc. So there is a lot to do still to prevent the cliff effect to whatever emergency that may happen, emergency or event like a weather. Now we've seen that we have more and more dramatic weather events. It's not worst, but we have more turbulences, more huge thunderstorms, and the pilots sometimes they feel behind a bit the aircraft and what's happening.
Thanks a lot, Yann. I would close on the last point. You should never feel behind. That's our problem, our common challenge to all of us. We should be always at least in, or even better, a bit ahead. Yeah. So many thanks. I'm sure we will come back on that with other questions. Looking at just changing, so the next one is, are authorities and the other CAAs prepared for approve and or audit AI use in the industry? I'm afraid it's for you, that one, Koen.
Very balanced answer. It depends. For example, we talked about this example of using AI in education. That's probably an easier one to solve, and we will cope with this. That's not that difficult to cope with. But if you look, for example, on what is happening in U-space, so the drones, and the ATM within U-space, this is so disruptive that we are not able to use everything that we used up till now to, for example, look at ANSPs and ATCOs. It will create a very different environment. And that's something we still need to deal with. This is technology that is evolving. We are not there yet, but I expect the first use spaces to arrive in 2025. So it's technology that is still moving. We are not there yet. It's very disruptive. You can't compare it with the current way of ATM. So in that area, for example, we are not prepared yet. We are working on this. We are working on this very fast. But technology tends to move faster than we can. And for that reason, we need to collaborate, and we need the help of EASA, for example, to cope with this.
Absolutely. Thanks a lot, Koen. So maybe we go to the next one. Does the use of AI invalidate our current risk assessment schemes as they have evolved using data within human inputs and consideration of acceptable risk level? That's a very interesting question. We have our AI program manager in the room, so I have to be careful in what I say, because I am under scrutiny here. I think we are back to the notion of learning, of model learning, and how you train a model here. I would slightly twist the question here. How can we make sure that when we use a model, this model will still satisfy what we expect from it? So that the learning assurance, sorry to use the buzzword, but for true, and how to ensure that what the model learns from what we input is reliable and explicable enough to be trusted in the end. If we can do so, and again here it's a matter of learning assurance, it should be okay. If we are not able to do so, if we are not able to ensure that the model is trained properly, and that the data set is acceptable with the right accuracy that we are expecting, then indeed we may have a problem. And that's what we are working on. I'm summarizing a long story very short here, but we could speak for ages. So in short, the reply is, if we do our work properly, with a big if capital, if we have learning assurance models which are accepted and which are trustable, it should be fine. But this is still, let's be honest, work under construction. And it is not the end of the story. We have still a long way to work together. And here, back to what we said before, what Yannick said, importance of the data set, importance of having really non-biased data set is really crucial. Because we can do the best. When we learn from a model, from a data set which has some bias, we are lost. And that's what we're working on with industry, with SDOs, and I mentioned it, avant growth, but that is really our challenge for the next few years, how to have this transformation and how to make sure that indeed we can trust what the model has learned. If any of you want to comment, Rolf, I was sure.
Maybe comment. I think it's slightly linked to the previous question on how to increase safety by the factor of 10. And I think there's no silver bullet for this, that we have, if you take a flap or whatsoever, we cannot build 2-3 more actuators in that or that. But already right now with the A350, we have a variable camber, so that the flaps already work in high speed to adjust the center of gravity. We have the ailerons, which already do something for takeoff and landing, so that we have more components acting together. And that would be one way, I think, to increase safety. In the past, we had just one job for a flap. Now with flap and the ailerons and the spoilers and others can do more. And with this, we can increase. And that asks for different sort of training and different sort of correlation. Correlation is a good part for AI. If it comes to reasoning, it's more difficult, and AI being not deterministic. So we don't know what will come out of it for the next time. So that will ask for humans. And with it both having diversity in the tasks, having the right requirements, and having the humans who have a look at it, we may be able to increase the safety.
Many thanks, Rolf. Maybe back to your tools, Mark. I would even say, back to what is written here, it is not invalidating, it could reinforce the risk assessment. Because if we have, again, the right data set, it will help us, when I say us, the manufacturer, the operators, and the authorities, to have a proper, refined risk assessment. Would you agree?
I think it's. I've been sort of thinking about this as you've been talking, and risk assessments, and I think legacy. We've been spending a lot of time as a human trying to sort of identify what the causes are and so on. And I think I think there's a balance to be had here about how much you would let AI interpret these, issues or whatever it is you're performing a risk assessment on, to make that decision for you. And I think it goes back to sort of what I was saying in my sort of presentation, that we've got to be really sort of careful around how much freedom we give AI to really guide our decision making. What I would see, though, is that the risk assessment can really be enhanced by the intelligence that the AI will allow you to glean from the data that it's assessing. On that, I think it's a very good point about the validation and invalidation of the previous risk assessments. And what I would be saying is it would be a very good idea that once you have an AI model in place, is to go back and reassess those risks in a new light and see what those deltas are in terms of what did we think before and what do we see now. So I think there's opportunity. Again, it's all about the opportunity that these things present to us, but absolutely, I see invalidation and validation at the same time through that process.
Okay, many thanks. So let's move maybe to the next one. Quickly, Mark, on this Gen AI.
Yes, I saw it come up, and thank you. So I think it's a really it's a good question, and maybe we have more time. I would love to cover it, but essentially yes. The answer to this is simply yes. We have to verify at the moment that any translation is equal to the initial intended message of the report, because what we did see initially is actually where Gen AI was kind of putting it into this human understood language or layman's terms for a lot of sort of reasons, is that the actual context of the incident that was being reported had fractionally changed in the way that the generative AI had sort of interpreted what it is that was being read. So super essential, and obviously we're not releasing anything into sort of the public domain. We're still working through this as a trial and how we adapt and how we validate. But of course, what I would say is this work came about because of the fact that we were doing some really in-depth work on runway incursion and runway safety in general, and we found that there was actually some really important data that we hadn't been either classifying or paying attention to in the narratives. And it was suddenly those kind of light bulb moments. You think, how do we get better use of the narratives, not just what an airline is applying as a taxonomy on the report that it submits? So this is the journey that we're on, and I think it is we've got to learn to walk before we can learn to run. But it's sort of envisaging the future. This for me is super exciting, and obviously what we want to be able to do in sort of longer term is extend that to things like FDX, which is for all money the FDM program that we also have. So we look at flight data with the same concept, because I think hidden in this mammoth mountain of data is really where our story lies, and it's getting to that's the important thing for me.
Well, many thanks, Mark. Maybe there is a very bold and less bold question. So let's not to escape the very bold question for sure, but there is a logic in reverting the two questions. I hope the audience will agree. To start with eMCO before talking about SIPO. So very quickly, Yann, in the last few years, your views on this question.
So which one do you want?
eMCO first.
eMCO first. So just for you to be aware, the concept of enhanced minimum cooperation is taking advantage of the high level of resilience of a 350 to take off as a true pilot and take advantage of a quiet cruise period to have one pilot resting while another one stays alone in the cockpit, and then they come back as a true pilot for the approach and landing. That's the concept. So why did we work on this? It's because today, as I said, the level of safety is reached assuming that we have two pilots at the same time awake in the cockpit. Today, when one pilot is leaving the cockpit to go to the restroom or to stretch his leg, it's not covered by certification, by operations. It's not covered. Today, when you have controlled rest, meaning one pilot is sleeping on his seat and the other one flying, it's not totally covered. And the last case, and we have occurrences of this, when you have the two pilots sleeping, because that happens also, it's not covered at all. And so the eMCO was studied to cover two phases of one pilot remaining in the cockpit, being alone. So we want him to be able to cope with time-sensitive emergencies, or giving him the time to call the other pilot back in the cockpit and resuming the two-pilot operation. We can't do this on a 320, on a 330, and on a 380. Only today we can think of this on a 350, and maybe in the long run we won't achieve it because, as I said, it's going to damage the level of safety. But as we study eMCO, we're studying a bunch of side functions that will, in the end, help the two-pilot operations. For instance, emergency descent, it can be a thought of function for a single pilot eMCO operation, but in fact today, the two pilots are very happy to have this function on board. So in the end, as I said, we're studying all the available technologies to go as far as we can, and so we're studying all the side effects, but maybe in the end we won't do it. So eMCO basically will be a safety function to better manage the fatigue, and in order to have at the arrival two well-rested pilots to land the aircraft. That's the aim of it.
Thanks a lot, Yann. It is consistent with what we had as opening speech from Florian in terms, we want really to work in the today's environment, and we want to improve safety, or what you mentioned also, Yannick, to improve today's safety in today's environment using today's ConOps and crew management. So any learning from this eMCO research development, which can benefit today's operation in today's environment, will be a safety benefit. And as we said, the safety level is so high that we have to make sure that we can maintain it despite the growth of the traffic. So we are really here aligned in terms of approach to this research on eMCO in a way that the learnings we got from this will help us. When I say us, it is industry, the authorities, the operators, to work even in a more safe, even a safer, but in today's environment with today's ConOps, which is quite comfortable in terms of increasing the pace of the change on today's aircraft. And this smart automation, this advanced automation we are using will help, as we said before in the previous presentation and discussion, will help all of us to confirm with the public, to guarantee the public that they are flying in a safer and safer environment. That would be our basic approach, and that's what we're working on together from a common industry and certifying authority perspective. So with this, unless panelists have other comments on that question, I think it allows us to answer very simply the very bold question which is following about the single pilot operation. Since we are not yet at a stage where we are envisaging to have some refinement in the ConOps to allow this approach, since AI is not yet ready at all to provide us with the right level of trustworthiness and certainty, and it would be highly dependent on AI tools, whatever they are, I believe we could all agree that it is an extremely long-term, not even vision, it's probably too early to think about it, because the single pilot failure case is the unmanned aircraft.
Yeah, well, just for everyone, SPO is at the opposite of eMCO, is one pilot taking off alone and doing the mission alone and landing alone. And today, working on this means that we work on a zero pilot aircraft, and we just don't have the technology to bring this aircraft to carry passengers at the required safety level. So we just don't have it. And end of the story for the moment.
Very good. Thanks a lot.
I think we are reaching almost the end of our panel. Time for a wrap-up. I thank you all first for your contributions, for your presentation, for your spontaneous answers to questions which were not always that easy. But again, it is really well aligned with what we heard in the keynote speech before: data sharing, safety improvement, aircraft resilience, training, competence development, how to do more research to ensure that collectively we can develop the competencies. So how to enable the new technology to step into our aviation system in a safe way, without, and that would be the word of the end, Koen, if I may say, maybe giving you the floor for this one, without forgetting that we are very good at developing new technical solutions with manufacturers, with the certifying authority, with the research, the GUs, as you mentioned. We come with very brilliant ideas on how to fly greener, how to have new propulsion system on board. But also we have to think about how to, and that's probably the most critical, how to do the oversight in the field. Yeah, and that's where we really have a common challenge. Developing is nice, introducing new technology is nice, but I think, Koen, maybe you want to conclude on this one, how to ensure we can collectively do the oversight from the design to the maintenance.
I can only agree with what you're saying now. Yes, we need to progress. Yes, we need to use technology to its fullest extent. But don't forget the oversight. We need to make sure that it's done in a safe way. And we can only do this by collaborating between CAAs and EASA, between EASA and industry, CAAs and industry. We need to collaborate. We need to progress, but also with safety and oversight in mind. And that's my call out.
Many thanks. 30 seconds for each of you, maybe also to make a concluding statement from your perspective on the learnings from our panel today.
Yeah, I mean, I think it's great to hear from the industry side of the OEMs what they're planning and all the rest of it, and also the challenges being faced by the regulatory community from which I left just over 2 years ago. But I think I would probably leave with the thought of we really have to be cognizant and challenge ourselves to make sure we know the difference between what we can do and what we should do when it comes to AI solutions and how we use data going forward, because I think that's going to be the challenge, because the ideas are vast, but actually we should, do we need to stop and think and say, where's our focus? What should we be focused on to utilize the tools in the best and most effective way?
Thank you, Mark. Wolf.
Yeah. I'm just asking myself, you may know that in the German Aerospace Center, we carry out the pre-test for Lufthansa and for the German air traffic control before they start their education. And so this is asked for a specific sort of test, and I'm just asking myself, what type of pilots we will need in the future? What requirements will there? They will be different from the past. When 1947, Chuck Yeager broke the sound barrier. He was a tough guy and could handle an aircraft. The new pilots will be different. And if it's a single pilot, it will be still even more different, because we cannot discuss everything. So what are we asking for? Not only for technology, but for the humans. Will be interesting.
Thank you, Wolf. Yann.
Yeah, just to remind that Airbus alone has 9,000 aircraft on the backlog. So more than 10 years of production of 2 pilot aircraft that will fly for 30 years. So we're very far from having a single pilot coming out of our final assembly lines.
Thanks a lot. And maybe because there was a question on Slido which was about rule simplification. Just one comment on that one, and I'm sure, Koen, Mark, you will agree from your authority perspective. Simplification deserves a bit of explanation. We already have, as experts, all to shift from this kind of prescriptive approach to this real performance and risk-based approach. And for the operational aspect on the competence-based, of course, but to have this mindset change. If you disagree, let me know, but I'm sure you will agree. To have this mindset of shifting from compliance, pure compliance, to how to ensure that the function is functioning properly and is safe. And that's really difficult, and I think we have a collective effort to undertake, all from industry to authorities, through research and academia, to inject this new mindset, because it is very challenging to people. Experts lack certainty.
And as an enabler to innovation, to new technology, this is probably one of the most difficult to quantify, but critical strategic change, the mindset to be performance risk-based altogether. And then data sharing will become easy. And if we have no more comment, question, I would call it today for today on our panel. Again, I thank you all for your contribution. Remote thanks again to Anna van Groot from EuroKI, and we look forward to a successful continuation of this conference. Again, thank you all, and thanks for the audience.